We are screen sharing, and I think we're live. Hello, hello. My name is Alexander Booth. I am the course facilitator for the October IBM Data Science class. So glad you're with us. If you're watching this, I appreciate you. Leave me a like on in our class forum so I know that you see this. But yeah, this is gonna be just our quick week 6 recap, and then we're gonna dive into week 7. Almost done. Kind of crazy. Just I think we got 4 weeks left. I was going ahead through the capstone. There is some new material during weeks 9 and 10, but it won't be as much as some of these the last few weeks. And I think you'll also love what we have to talk about with week 7 as well. Anyway, if you joined us for our live session last Monday on November 10th, thanks so much. If you watched it, the recording, even better. So please go ahead and watch the recording of last week if you haven't already done so. I've got it in a couple of forum posts. This is still in week 6. So you can watch the recording either through the IBM campus, or you can just watch it straight from Zoom, whichever is easiest for you. So what we're talking about in week 6, kind of how did we get there and kind of where are we going? So I like to think of it as like week 5 was kind of more about EDA, pre-processing and introduction to modeling, which is actually going to be a little bit similar to what we're going to cover in week 7, but I'll go into the differences here in a bit. Now, with week 6, we took a step back and only focused on visualizations. How do we tell data stories? How do we create different types of graphs and visualizations? And then how do we even go that next step into interactive dashboards, right? So quick ideas of just what you missed in the live session and kind of some other bits and pieces of week 6 that I want you to try and take away. So first, the creative side of data science, right? Data science isn't just mathematics and statistics. We also need to use left brain, right brain. We'll Google it. Which brain side is creative? Left. Left. Look at me into saying, I think left brain or right brain. Yeah, whatever. Whatever side of the brain you are, what if you're more creative, more artistic? I always love kind of talking to folks who kind of move into data science from more creative pursuits. And I'm like, hey, yes, please put your ideas and best practices to work here. A little anecdote about myself. I actually had a minor in theater, technical theater. I did lighting and set design. So I actually freelanced as a designer for a couple hot summers back in the day. But it was really interesting being able to talk about color theory and how to relay emotions and signals on kind of a theatrical stage. And it's the same kind of idea on a visualization for data approach too. Different colors evoke different feelings and emotions. Our eyes are drawn to different locations based on color and positioning. And as we try to tell stories with our graphs, that really comes into play, right? I say we don't just make graphs just because we want to make a bar chart, right? We have each of our graphs should tell a purpose, right? And that's even involved with dashboards as well. Honestly, maybe I'll actually, as we get into it, I think I brought up like my background's also in sports analytics and baseball. And it's really interesting talking about some of the like advanced reports. Let's see if I can find just like a pitcher report. Let's see what we can find here. Who should we know? Who plays baseball? We'll find a Shohei Ohtani. See if he pops up. Maybe it's because I have the day wrong. Let's pick November 1st. Player visualization report. I wanted to find a player breakdown. Anyway, I guess we can just do something like this. I was gonna see. I wanted to find his actual. Here is how bad I am at actually working this site. Whatever. Show just like, hey, like as we start creating dashboards, right? We do it to tell a story, right? And see, we have a combination of like bar charts as well as leaderboards and tables, which I was trying to move a little bit more away from. Maybe this will be the player scroll if we can click on that. It is. Here we go. So this is what I kind of want. I really like. There's like an interactive kind of dashboard just about this guy like throwing baseballs. We're gonna see that the color is used. So he threw 51 pitches, and if we keep scrolling, we can see how the visualization changes. Obviously, we're red fastballs. That's our big fast pitch, and that takes up a majority of our graph. And the other ones kind of throw around too. We can see how his fastballs differed from the rest of his pitches, blah blah blah, curveballs, blah blah blah. So again, this is interesting. Like if I was actually trying to do some like statistics and analysis on this, there's some really interesting stories to be told here. But you can kind of see like we have all these different pitches that was thrown, and we can kind of see how they looked when he released it. So we already kind of see through kind of one pretty weird curveball that kind of was a little bit different than the rest. And yeah, we can see that same curveball that he threw a little bit higher actually ended up like way outside the zone. It's one of his worst pitches, which is kind of interesting. Anyway, like what I want to get at is there's a story that's being told here, right? Like how are his pitches for balls, strikes, which ones were kind of hit hard, etc. And that's kind of the point of data storytelling, right? We want our graphs to tell a story to try and kind of compel the users to interact with our reports, and again, hopefully lead to decisions downstream. So we finally get here that he only had two hard hit baseballs, which is probably pretty good. So he had six that were not hit very hard. So he probably had a pretty good game looking at this, which he did because I watched this game. But yeah, again, big idea that I want to convey here. We're using different visualizations, leaderboards, and interactivity to tell stories, right? And that's really where that creative aspect of data storytelling comes into play. All right, we'll fly through some of the rest of this because I don't want this really to be a long video. But some of the things that I talked about in the live session that were only hinted at during the course, a little bit of the history of data visualization. I brought up Napoleon's March and Florence Nightingale's, which I linked down below. These are both really, really classic data visualizations from history that really do a good job of telling a data story. And they're both like 200 years old, which is awesome. Florence Nightingale is actually known as kind of one of the mothers of data visualization from her work in the 1800s. We also talked about Edward Tufte. So Edward Tufte, if you don't know, he is still alive. He is a pioneering statistician and professor around data visualization and dashboard design. So he's got some really good kind of theories around how visualization, statistical visualization should be presented. You'll see all of his books, how to display quantitative information, beautiful evidence, visual explanations. He's got some really, really good stuff. So we talked a little bit about him. I recommend kind of doing your own research on some of his ideas, but the big ones to take away, data to ink ratio. Try and make sure most of the ink on your visualization is related to the data. Avoid chart junk. Keep them clean, keep them professional, keep them good storytelling. Try and maximize clarity with minimal clutter. I also like to add, like, try and have that call to action pretty evident from your visualizations as well. We also talked about color theory. One of the big, I guess, there's a couple big things around color theory to bring up. So first is red versus blue. Those are going to be your most common colors used in visualizations. Red, hot, kind of draws the eye. Blue, cold, maybe we're not so good. Again, you don't have to know too much about baseball. Let me just pull up Jock Peterson. So if I look at this guy, um, the idea, oh, I guess he didn't play enough to qualify. He was the one of the worst guys in baseball this year, like qualified. I'm like, oh my God, I don't even know. Brain is fried. So maybe I'll just pull out, I always like, I used to pull up this guy back in the day, because he was always really bad at baseball for a long time. Let's see if we can finally grab a year, maybe like 2021 or something. Yeah, there we go. So looking at this guy in 2021, you don't have to know too much about baseball or statistics to see that he was pretty bad at hitting baseballs, right? We have a lot of blue, a lot of small bars. Contrast that to someone who is really good at hitting baseballs also in a sec, and you'll see that, oh, wow, like that's really compelling. But again, you don't have to know anything about baseball either to be able to look at this chart and say, oh, you know what? This guy can actually play defense. a little bit, right? He's got a lot of red on his defense. So he can't hit, but at least he can play defense, and maybe he'll become a defensive kind of specialist. So contrast that to someone like Aaron Judge, who just won the MVP award earlier this week. And whoa, yeah, again, you don't have to know anything about baseball to be like, is this guy good at baseball? Yes, a lot of red, a lot of really tall bars. Right, so again, the story that I want to convey here is just by using color, right, red and blue, we're able to really like convey information pretty quickly without even having to look at the numbers, look at the statistics. Like it doesn't matter, right? Like this guy is good at baseball, the other guy was not so good at hitting baseballs, right? So again, it's really interesting how that color can convey this. So that's the first one, red versus blue. You'll see this a lot in color theory. And the second is kind of avoiding colors that can be hindered by color vision or color blind people, right? So you'll see that a lot of data viz actually don't go into green and purple and brown territory just because it's not as accessible as some of these other primary colors. Cool. We also spent a decent amount of time talking about what makes a bad graph. We spent some time on data is ugly and some of the kind of political visualizations I've seen over the last few years. So again, with misleading scales, truncated axes, pie charts that don't add up to 100. Just let me just pull up a couple right here. Let me just grab one. So this is a class. This is a very famous one from like a decade ago. It's a pie chart that obviously does not add up to 100. And then here's another one that's pretty classic. This is a little bit more recent, but you'll see that this is a bar chart. But if you look at the axis, it goes from 58% to 78%. So what that means is that this difference of 77 to 65 looks much more dramatic, right? If I had my scale go from 0 to 100, like it probably should, a drop of 12% isn't nearly as dramatic as this. So you'll see this a lot. Misleading axes, misleading visualizations, percentages that don't add up, right? All that good stuff. Yeah, kind of same thing here on the y-axis. We go from 8 to 10%, but they've really compressed the axis to kind of make some of these differences look a lot more dramatic than they probably should. Oh yeah, same thing here. For more percents that don't add up to 100. Love it. Anyway, we talked about like what is some common pitfalls there for visualizations. Then finally, we went over some of the lessons in week 6. So we reviewed Matplotlib and Seaborn, as well as Plotly, and then Dash for interactive dashboards as well. We talked a little bit about dashboard design down here as well. Everything was kind of backed up into my GitHub. So if you want to review the actual notebooks from the live session, we reviewed one of the big Matplotlib assignments, and then we reviewed Plotly and Dash as well, or the last like big activity around wildfires. So if you want to look back at that code, it is all there for you. Definitely recommend doing 612, 613, which is Plotly Dash. 613 is like the key activity for the week. And then 6.7 is all about static visualizations, Matplotlib, Seaborn, all that stuff. Definitely recommend reading through some of the extra materials. And that's it. So, in summary, week 6 here, I want you to think about what is a good visualization, right? And so, what are some of the key ideas around design, storytelling, artistry, and then what are some of the pitfalls that you may hear from like bad visualizations, right? Again, at the end of the day, it's use color to your advantage. Try and be contrasting with your colors. Be truthful in your data, right? You are truth telling as well as storytelling. So watch out for your axes, your percents. Never really try it. Never let your viz lie. And then also we talked about Tufte's principles. So your chart to ink ratio, removal of chart junk, all that good stuff. Let's see. Yeah, I had fun with week 6. It's a lot of content, it's a lot of labs, but they go by pretty quick, and there's nothing that's too overly complex, confusing, or technical, which is what I like about it. Try not to get too bogged down by some of the matplotlib syntax or Seaborn syntax. Try and stick true to the big ideas of dashboarding best principles and visualization best practices. All right. We're taking up way too much time here. So let's jump into week seven. Week seven is a pretty straightforward week as well. Some of the big ideas for week seven, I'll pull up my big ideas for things that you're supposed to get away from this week. Identify the different types of machine learning. Specifically, I need you to be able to define regression versus classification under supervised machine learning. You should be able to give me the linear models for both the regression and classification, including linear models or regression models, ordinary least squared models for regression, and logistic regression models for classification. Even though logistic regression has the word regression in it, it's actually a classification algorithm. We'll also talk a bit about random forest algorithms as well this week. I'll put some of that into practice in the live session, but we'll go more deep into random forests next week. You should be able to talk about the life cycle of a machine learning model. So your experimentation, pre-processing, feature selection, model training, model evaluation, and model deployment. I think I can actually pull up a pretty good picture of that. Model it's called MLOps. Let me see if I can find a good image. We'll talk about this in the live session as well. But basically, develop data prep, EDA. Wait, I guess EDA, data prep, develop, train your model, review your model, deploy your model, use your model live in production, monitor the model, and when you have to go back, you need to kind of just do it all over again. We will be talking a little bit about MLOps, even if we don't actually drop that word. But design, development, and deployment or operations, I call it deployment as well. Oh my God, so many yeah, AWS, that's AWS for you. Giving you just a crazy diagram here. Cool. So we're going to talk about MLOps and yeah, data scientist versus like AI engineer. Basically, long story short, AI engineer is a generative AI developer, which again, there's a lot of crossover with data scientists, so don't be too hung up on those definitions. And then we'll kind of dive into some hands-on work with linear regression and logistic regression. So to do regression models and classification models, and then be able to understand how to evaluate both of them. So again, if you're following along with Scikit-learn, last week we did or week 5, we did our high level like introduction into regression, EDA, pre-processing. This week is going to formalize a lot of that for regression, as well as introduce classification algorithms as well. And again, you should be able to know some of the key metrics to use to be able to evaluate classification algorithms. So let me dive into just week 7 here. Only one discussion prompt. So again, please respond to the discussion prompt here. Shout out to Ryan for being ahead of me on that. Let me make sure I click follow on all these. Boop, boop, boop. Cool. So only one discussion prompt, so try and get that knocked out this week. And you'll notice we actually only have 3 labs as well, which is great. So 7-1 is a decent amount of lecture and theory. I highly recommend you kind of watch all the videos in 7-1 and 7-3 too. There's a lot of videos to start. And then 7-3 we'll dive into 2 notebooks for regression. Again, these are all backed up on my GitHub now if you want. So overview of simple linear regression, which is just the one feature predicting one target. And then same thing with multi-linear regression, using multiple features to predict one target. The big difference of this versus week 5, again, standardization with scikit-learn, standardization with your pre-processing pipeline, and standardization with your evaluation. You'll notice that at the end of 7.3, we're going to be looking at your mean squared error, your mean absolute error, and your R squared for a lot of these problems and building out some interesting visualizations. And again, trying like how do you actually tell and evaluate how good your model actually is. Then you move into 7.4, which is classification. Again, I highly recommend taking that time to really watch the videos here. They're pretty important to understand. We haven't really talked about classification in this class before. And then there's only one notebook on 7-4. 7-4, even though there's only one notebook and it looks quick, at the end, it gives you your activity, your main activity for the week, which is going to be giving you all these practice exercises. So you actually have 5 questions here. No solutions are given to you, so try and work through all those on your own. If you need help, I've already done them, so you can also just look at what I did in my notebooks here as well. Uh, During the live session, we're going to review both linear and logistic regression, regression and classification, and I'll also throw in a couple extra introductions for random forests and things, which, like I said, random forests, MLOps, those are all brought up in the lectures or in the videos for week 7. Sweet. Looking even further ahead, week 8 is going to be a little bit more in depth on random forests and kind of those more exotic algorithms, as well as we're going to pivot into this other section, clustering and dimensionality reduction within scikit-learn as well. So this is typically known as unsupervised machine learning. So we're going to continue to do some more advanced supervised machine learning and introduce unsupervised machine learning next week. And then we have Capstone Week, which is going to be a lot of fun. Again, we have some real world projects that we're going to be building as we kind of walk through all the media sets for weeks 9 and week 10, as well as learning some additional concepts around geospatial data and neural networks and all that good stuff. All right, I think that's it. Big ideas. Week 6, what is a data visualization? What does it mean to use art to tell a data story? Week 7, more formalized introduction to machine learning. Not only are we going to expand on what we learned a couple weeks ago on regression, we're going to introduce and walk through classification models as well as evaluation tools for classification models, and tying all that back into MLOps and a machine learning pipeline. And then in week 8, we're going to dive deeper into unsupervised machine learning, as well as some of our more exotic and newer algorithms like our trees and neural networks and things. All right. Only one forum post for week 7. So please do that. There's also only one forum post for week 6 as well. So highly recommend you just drop that in as well. I love kind of seeing the engagements in some of the forums. So as always, Karen's and the TA's been doing a great job dropping some awesome additional knowledge in all the lounges. So again, so much material, so little time. Last thing I'll just mention here, there is I'm going to drop this as an extra credit for week 7, the Intro to Machine Learning Kaggle Learn. Like I said, since week 7 is pretty light on labs, if you want some additional hands-on content, the Kaggle Intro to Machine Learning is some great supplementary work for this week. And yes, we'll be sharing the advanced machine learning, and I think the feature selection one is unsupervised. Uh, Let me just confirm that. Yeah, K-means and PCA. So we'll share both of these as extra materials for week 8 coming up next week as well. Yeah, the intermediate machine learning is kind of relevant to this week as well. If you want to do a thing on that, work your way through that as well. I'll drop both of these links in my recap summary too. All right. Thanks for listening to me ramble for a little while. Hopefully, this was helpful. Next live session is Monday at 7 p.m. GMT, 2 p.m. Eastern Time, and I will see you there. That's November 17th at 2 p.m. Eastern. Otherwise, I will upload the recording at least by the next day. Cool. Thanks, everyone. Reach out if you have any questions. Good luck with this, your work this weekend. I appreciate your time and engagement as I do every single week. So great job. I'm proud of you for being engaged. Thanks for watching these videos, and I will see you all in our next live session. Have a good weekend.